Yes, I recorded a wonderful video last period, and yes, I did not realize the microphone was not on, so it was a silent video. So now we're doing it again. All right, so you'll be in the video today. Okay, folks, in example 4, we want to, in this particular type of eliminating the parameter, you actually are going to get a clue about what to do by looking at the picture. So if you were to graph this on your calculator, we talked about that yesterday, how you could use your parametric function on your parametric mode, and you could graph this. And what shape do you think it is? A circle, all right? We know from geometry class that every circle is some... Oh my goodness.
Oh my God, it was actually in my pocket.
Oh my goodness.
It was actually
Lost
in my pocket.
for
I'm
a
sorry.
week on the day of spring break. Oh, that is so sad.
I'm really sorry.
Sadness. Oh yeah.
I'm sorry. It was. I didn't. I'm sorry. I think
Mute
I
that thing, for crying out
I'm
loud.
sorry. I
Okay.
wasn't even on at that time. No,
You're right, because most of the other times I look over and I see.
Yeah, that's gonna be on the video.
You're right, it is.
You need to unlock your eyes.
Yes.
I didn't even know what it was doing. It's in my pocket.
Yeah. Most of the time I don't. Okay.
Well, actually, at least I'm being honest.
That's true. Okay, now, so the function from geometry is the Pythagorean theorem form, a squared plus b squared equals c squared, right? This is just, a generic circle equation. Now, what's the center of our circle? 0, 0. So our circle looks more like this. Okay? Now, we want to figure out what the r squared is. So we're going to do replacements. We're going to replace x. What should we replace x with? 2 cosine t. And what should we replace y with? 2 sine t. Okay? Oops, forgot my square. So when you square each one of those, right? 2 cosine times 2 cosine. What's 2 cosine times 2 cosine? No. 4 cosine squared. Right? 2 cosine times 2 cosine is 4 cosine squared. Is that okay? All right. What about 2 sine times 2 sine? 4 sine squared.
T.
T.
Don't forget the T.
I'm not going to forget the T. Who would forget the T?
That was a good one. I'm so. This video is going to be so much more entertaining than theirs. It was a
Whoa, shots fired. Okay. Yeah. Yeah, it's a riot. Okay, so what can you pull out of those two terms? 4. A 4. You can't pull a T out of there. It's attached to cosine and sine. And what's cosine squared t plus sine squared t? 1. Amen. Yes.
So ours too.
The therapy's working. All right, now.
Speed. Sorry, guys. Moving too fast.
Okay. So we got r squared equals 4.
You square it. Then x squared root.
So what's my equation? My parametric. We have eliminated the parameter now. What does x squared plus y squared equal?
2.
Thought it equaled 4.
Wait. Why would it equal 4 if r squared equals 4?
Correct. But remember, the equation is x squared plus y squared equals r squared. Now, it is true that the radius of the circle is 2. Yes, the picture showed me the radius was 2. Okay? Is there anything in the equations for x and y which would have told me the radius was 2?
The square of the 2.
How about the 2? Right. Right. There we we go.
I make life
Okay.
complicated.
Okay, we'll move on.
Well, I was gonna go
Now,
with
yeah, I was going to say,
I was gonna go
well,
with that.
you can always ask Siri about that.
I don't even know what it was talking about.
Yeah. Okay, now I am skipping example 5, okay, because it is almost like example 6, except the way they do it in the book in example 5 is kind of weird, and it's a little bit confusing. So, example 6.
Stop targeting me.
Okay, all right, we'll stop bullying you.
Thanks.
Find a parameterization of the line segment with endpoints, and then they give me this. Now, a line segment is a portion of what? A line segment is a portion of what shape? A line. Thank you very much.
Is a line a shape?
Gee whiz.
Wait.
Gee,
Is a line a shape?
is a line a shape. Okay.
No, it's not. It's a
Oh,
part of a
we
shape.
need spring
Just
break.
look. Is this a shape? No, that's not a shape. But if you have 3 lines.
But you drew it so
and you have a
well.
triangle,
Oh my goodness.
How do you draw a line not well?
Folks, I need to keep going
Why
here.
is a line a shape? You don't understand.
Okay. All right, you keep working on that one.
Okay.
So we need to use this, since it is a line, we're going to use the slope-intercept form. I'm sorry, the point-slope form. Okay, now, the point-slope form of the equation of a line is y minus y1 equals m times x minus x1. Okay, now I know what you're quoting me. You're quoting me the definition of slope, right? Okay, all right. Now, we're going to use a modified version of this formula. So, what did I do to both sides of the equation? I divided by x minus x1, right? That's how I got that part to move to the other side of the equation. Does everybody understand? Does everybody understand that these are variables? Okay. An equation of a line has to have variables. Oh my goodness. All right, now, we know how to calculate the slope. So I'm going to take these two coordinates, -2, 3, and 3, 6, and we're going to find the slope. So what do we do to find the slope? Subtract the y values, right? Difference in the y values over the difference in the x values. You guys learned that a long time ago, the rise over the run. Okay, so that is what? That is 3/5. Right? Okay, now, would there be anything wrong if I multiply the top and the bottom by t? I'll show you. But would there be anything wrong mathematically if I multiplied the top and the bottom as long as I did it to the top and the bottom? No. Okay? Because t over t is 1, we could get rid of that, but what we're looking at is y, and now we're going to take this as a coordinate. All right, now let's go with Miss James. Which one of these coordinates would you like to pick? You can pick the first one or the second one. What do you want? Okay, she's going with B, 3, 6. All right, that's the coordinate we're picking. Okay, so y minus 6 over x minus 3. So, do you see where these two equations are coming from? Do you see where those two equations are coming from? No. Okay? The numerator has to equal the numerator, and the denominator has to equal the denominator. Okay, now, solve each equation for this one for y and this one for x. So what is the parametric equation for the y? 3t plus 6. Thank you very much. What about for x? Okay, so you have just written the parametric form of the line. Now, this is the line. We want the line segment, which means we have to add a parameter for t. We have to tell it where to start and where to stop. Now, if you don't, you're going to lose credit because you did not complete the question. Trying to tell these people, but okay, so I do not care if we use the x or the y. Ms. Pushman, you choose. Are we going to use the x equation or the y equation? You get to pick. She's picking the y equation, but folks, it would not matter whether we pick the x or the y. So she chose the y equation, and what do we know about the lowest value and the highest value of y? If we zoom in, we see that the lowest value of y is 3, and the highest value is 6. Okay? So we got a 3 there and a 6 there. What do you think we're going to substitute for y? Nice. And now we need to solve for t. Stop throwing things. Oh my goodness, what's going on? Okay, so what do we do to all 3 to get rid of the 6? Subtract 6. Okay, from the left, from the middle, from the right. Negative 3 is less than or equal to 3t, which is less than or equal to 0. And now for our next trick. Divide everything by 3. Do any of the signs flip, or do they stay the same? They stay the same because we didn't divide by a negative number. Yes. 3 minus 6 is negative 3. So, not only do you have to tell me what x and y are, but you also have to tell me what the parameter of t is. And we would get the same thing if we went with the x's, because the x's are different. The x's would start at negative 2 and go to positive 3. So you would be using a different equation with different numbers, and you would end up with the same parameter for t. That's not going to change. Okay. Any questions about what we did right there? Okay. We should get the exact same thing. So you had negative 2 is less than or equal to x, which is less than or equal to 3. And you plugged in the 5t plus 3. And you really need some room here. 5t plus 3 is less than or equal to 3, which is less than or equal to negative 2. And let's see, you subtract 3 from both sides. Minus 3, minus 3, minus 3. And I got negative 5 is less than or equal to t, which is less than or equal to 0. Oops, sorry, that would be 5t. And then I would divide out the 5. And, oh look, negative 1 is less than or equal to t, which is less than or equal to 0. Yes! Nope. Nope. We always go with the smallest value on the left and the largest value on the right. Everything's less than or equal to. If you start switching them up, right, instead of both less than or equal to's, if you start doing this kind of crap, you lose. You do this kind of crap, you lose. Do this kind of crap, you lose. Both less than or equal to.
Oh my God.
Yes. Tomorrow, it'll be after break. So I'm not sure. I don't have it nailed down. Why? Do you Do you have a particular favorite day you're looking for? Wednesday? That's probably not a bad idea right there. Yeah? Okay. The quiz over this. Yeah. Just make sure you're back next week on Wednesday. That's what she asked for, so. What?
I have a math question. We'll get many of these.
All right.
So, I might have zoned you out. You said this.
Possibly.
So it doesn't matter which one we choose because they're both going to be the same.
The parameter will end up being the same no matter whether I start with the x equation or the y equation. Okay. Does that help? All right. It's not like it's going to be Monday, if that's what you mean. I don't do homework over vacation. I think that's a sin. Back in Algebra 2, we taught you about projectile motion. Okay, but we basically talked only about the vertical component. Stay with me. You really need to focus on this. We only talked about the vertical component. So part of this equation, part of this equation right here should probably look familiar to you. Except it looked more like this. Negative 16t squared plus the original velocity times the time plus the original height. That is what we talked about specifically in Algebra 2, and it's a comparison between the time and the vertical distance only. Now, you know when we launch something, typically we don't launch it straight up and it comes straight back down. Usually there's an angle that it is launched at. Okay? So what we need to talk about are the horizontal and the vertical equations. We never mentioned the idea of parametrics to you in Algebra 2. We were basically studying one of the two parts, but we need to focus on both of them. So this vector, v sub 0, has two components, a horizontal and a vertical. V sub 0, that velocity, is the magnitude of that vector, right? And we know how to find the x and the y component. Please stay with me. I need you to focus, not on the screen, that screen, but up here. Okay, so we know how to do the components. We know how to take the magnitude times the cosine of the angle and the magnitude times the sine of the angle. So that makes sense to us. And then we can use that in these equations. So let me zoom in on this one so you can see what it means. If you've ever done any distance equals rate times time problems before in your life, we called them dirt problems when we were in high school. That's what this is. This is a horizontal distance right here. So horizontal distance. What? What?
So this is Staileys Funny Shirts. I was understanding things. Now we're
just learning about dirt.
Yeah.
I'm going back to physics again, and I don't like it.
Okay, folks, it's not that hard. You'll get it. It won't be too bad here. All right. So the speed in the horizontal is here, and of course we have time on the end. So it's distance equals rate times time. That's all it is. Exactly, because you have to take that into consideration. Now the other equation looks a tad different, only with that middle term again, because the original velocity in the vertical direction is the v sub 0 sine theta. That's it. That's the only difference between what you saw in Algebra 2 and what you're seeing now. Okay, and yes, this term, the vertical distance, gets affected by gravity, and that's why you have the negative 16t squared, you know, that whole thing going on. Whoops, that wasn't it. So let's look at this situation. So the baseball is being hit 3 feet above the ground. Okay? And it's going to fly through the air and eventually come back down. The question is it going to go over the 20-foot wall or not? Is it going to go over the 20-foot wall? If the 20-foot wall is here, do you think it's going to go over the wall, or will it hit it and fall back in? It'll hit it and fall back in. What if the 20-foot wall is here? Then you're good to go, right? Okay, so now we need to figure it out, okay? How long will it take the ball to travel 400 feet? Okay, now, I copied and pasted this in here because I really was upset when I read this right here. A little experimentation. Folks, we don't need to experiment. We know that it's 400 feet. Why are they saying a little experimentation? I was like, okay, wait a second. I'm like, what kind of professional textbook is this, for crying out loud? So, if the horizontal distance is 400 feet, and we also know that the initial speed was 150 feet, and the angle that it was struck at was 18 degrees, we should be able to find the exact number of seconds that it takes this ball to get 400 feet horizontally. Okay, so grab your calculator, divide, and tell me what the time is.
400 by 150 goes like 18.
Which she's typing on her calculator, even as we speak.
Working with my friend
2.804 seconds.
Are you in the wrong mode?
Okay, make sure it is in the correct degree mode. That would be a problem. Ah, yes, must have been using it for the last half chapter. Oh, okay, must be a spare calculator. It takes 2.804 seconds to reach 400 feet from where it was hit. That's the horizontal distance and the time that it took to get there. Now, we need to use that in the other formula. We have y equals -16. We know what t is, 2.804 seconds, plus 150 sine 18, because that's the velocity of the vertical component, times the time, 2.804, plus the original height. What's the original height? 3. We have everything we need to figure out the vertical distance. Now, if this ends up being a negative number, that means the ball hit the ground before it even got to 400 feet, right? If this number's 0, that means it's actually striking the ground at 400 feet. Figure it out. Let's figure out what it is. Some of you are not participating. This is not making me happy.
Is it going to be negative?
Nope.
2.
Bang. 7.17 feet. Okay? Did it make it over the 20-foot wall? No. At 400 feet away from home plate, it's only 7.17 feet. It's going to hit the wall, folks.
Is it hitting the wall at 7.17 feet?
It is hitting the wall at 7.17 feet. Not even coming close. Good point. All right, now, let's think. Suppose we did this. Think. Listen. Look. Let's suppose it was 21 feet. So the ball is at 21 feet. The wall's at 20. Is it going to make a home run? Yes. Now, let's lower the wall. Let's lower the wall to 8 feet. Suppose the ball is at 9 feet above the ground at an 8-foot wall. Is it going to go over and make a home run?
No.
Well, aren't we there's some really good outfielders out there that got really good doggone vertical leaps, and haven't you seen them go like this, reach up over the wall and grab something when it's a foot? Now, why didn't I think that here, and why did I agree with you when it's a 20-foot wall and 21 feet? Because ain't nobody jumping that high.
Can someone jump 9 feet?
Well,
I mean,
people
ours
dunk
are
basketballs, don't they? That's a 10-foot rim, so I'm pretty sure they could jump up and reach over an 8-foot wall. So I'm just saying, if the wall is shorter and you think it's close, I might say it's possible that it'll be a home run, and here's why. Okay? If it's a 20-foot wall, it's definitely going over at 21. We're not going to have that happen. This one did not. It struck the wall at 7.17. And thus completes our video, and no more math for another week and a couple days.